All right, I'm going to be talking about how to find a mean and a standard deviation for a data set. So what do we mean when we say that we want to find the mean of a data set? So the mean is just the average. So in math, it's easier to think about if you have the sum of values over the total number of values. And so on any of these problems, you're going to be given a data set that you need to be able to extrapolate data from. So say you're given X, and you're given values 1, 2, 3, 4. When you're trying to work with data, it's going to be a lot harder to try to sit here and do anything with these individually. So, but we can take this and find the average of that to just get one value. So to do that, take sum of values, so that's 1 plus 2 plus 3 plus 4, and that's just going to be 10. And then the total number of values is all the data that you were given. So you're given 1, 2, 3, 4 values. So you're going to take 10 over 4, and that's going to be the average of this data set. And that's just going to be 2.5. So that is the average of these values. And you need to start out with learning how to do this before you can find the standard deviation. And then the formula for standard deviation, after you get this, it's represented by the Greek character sigma, and then it's the square root of the summation of any individual x value minus the x bar, which is your mean. So x bar equals mean squared all over. And it always depends on what kind of data that you're using. So there's two different ways to do this. You'll either be given a sample or a population value. So let's say this one is sample. So you're going to use n minus 1. Now the n value is this number here. It's going to be the same as the total number of values. So for this, we know that n equals 4. And then for a population, we know it's still represented by sigma. It's going to equal basically the same thing. So it's initial x value minus the mean squared. But when you divide on this one, instead of just using the sample of n minus 1, you use the actual total. So it's just the n value. All right, I've got a few examples prepared that we can work through together. So a sample was done collecting the data below. Calculate the standard deviation to 1 decimal place. So this is our data table where we're given our x value and 5 different values in our data set. When I tackle any of these problems, the first step that I like to do is calculate the mean. So I'll do step 1. Calculate mean. And so on our previous example, we learned how to do that. We're going to take 18 plus 22 plus 17 plus 1 plus 7, and then we will divide that by the total number of values we're given. That's 1, 2, 3, 4, which is 5. So we know n equals 5. Divide this by 5. So you can see my calculator here. 18 plus 22 plus 17 plus 1 plus 7 equals 65. So this simplifies down to 65 over 5. And then we divide 5. So that gives us, our mean is 13. So x bar equals 13. I like to circle these because we're going to need these values later. Let's go ahead and switch colors. So anytime that I'm given a data set, like I have this one very small on this example, but I like to go ahead and step 2, we're going to find the deviation from the mean. So take this, and what I like to do is I like to make another chart right around here, but I'm gonna rewrite it all down here to make it bigger and easier to see. So take this, x 18, 22, 17, 1, 7. Okay, so we can extend this out. So, and then we'll write deviation right here. So what we're doing is we're seeing how far away this value is in our x portion of our table away from the mean. So what that looks like is 18 minus 13 equals 5. 22 minus 13 and that's going to equal 9. 17 minus 13, that's going to be 4. 1 minus 13, that's going to equal negative 12. Let's back up here where you can see it. And then we got 7 minus 13, which is going to equal negative 6. So this is the complete step 2 part of this table right now. So the next part, we're still going to be working on this table, but we're going to extend it even more. So we're going to find our deviation squared. I'll go ahead and finish out this chart in pink since I started it that way. So go ahead and label that step 3. We're going to take this value for each one of these and square that value. So that's going to be 5 squared. That's going to be 25. 9 squared. That's going to be 81. 4 squared equals 16. And then negative 12 squared, 144. Negative 6 squared, 36. Okay, that's the complete step 3. We've taken this data that was given to us to begin with. Then we found the deviation in step 2. And we squared that value for step 3. So we're left with all these values here. So then we can move on to step 4. So step 4, and I'll move this so you can follow along with me. What we do is we take this value that we found right here in step 3, and we're going to add all of these together. We're going to find the sum of our deviation squared, which is going to be 25 plus 81 plus 16 plus 144 plus 36 equals, I'll calculate this with you, 25 plus 81 plus 16 plus 144 plus 36. That gives us a value of 302. So 302. So this value here is very important to us when we look at the equation for standard deviation. So you have the summation of this right here, which is this value is your deviation squared. So this formula here looks more daunting than what it really is, because if you look at what we just extrapolated from the data, we have already calculated the summation of this on step 4. So this 302 gets plugged in right here on this whole line. So we'll go ahead and move on. I'm gonna go up here to step 5. So you plug step 4 value into formula. So I can go ahead and do that. So sigma equals the square root of 302 over, and then we know right here n minus 1 is what's on the bottom of this. Well, we've already found that in this example that n equals 5. So that's going to be 5 minus 1. And we'll come on down here. 302 divided by 4. And this is going to equal 75.5. But we're not done yet. It's really easy to think that this is it if you don't bring your square root down. So we're going to square that value. The easiest way to do that on the calculator is put the square root symbol and then second negative symbol. That way you get your answer from the previous step under the square root. That's going to give us, right here it says 1 decimal place in this example. And I also used n minus 1 here because in the example it also said it was a sample. It's very important. But if it did say population, then we would have, instead of n minus 1, we would have just used n value of 5. So let's go ahead and finish working this out, or writing it down on the paper rather. And we're going to 1 decimal place. So the answer that we're going to go with is 8.7. And that is your standard deviation for this data set. All right, I've got one more example too, and we're going to do it the exact same way. It's the same thing. It's calculate the sample standard deviation of the data shown. And this one, first thing, it's wanting us to do 2 decimal places. And then also, first thing you're going to do is make sure what this says here, if it's sample or population. So go ahead and start working this one out. So we know step 1 is always going to be to find x bar. So x bar is going to equal 15 plus 22 plus 30 plus 17 plus 16 plus 19 all over 2, 3, 4, 5, 6. You don't have to write these down. I just do that to give it a clear visual on the video. So we know we have 6 values in our data set. So that's all over 6. And then we'll work that out. X bar equals 15 plus 22 plus 30 plus 17 plus 16 plus 19 equals 119. All over 6. So X bar, simplified all the way down as we can go, is going to be 19.8. So very important, because this is how we find our step 2, or deviation. So switch colors again. So step 2. And just for video's sake, since this is so small, it's a lot easier to do this if you handwrite it. Just copy that data again. So X 15, it gives you a little bit more room to work. So step 2, again, let's find deviation. So deviation. What that means is it's just how close to this value is to the actual mean itself from the data. So 15 minus 19.8. It's going to equal negative 4.8. Well, I made my graph a little short there, but that's fine. And then 22 minus 19.8. 2.2. 30 minus 19.8. 10.2. Then 17 minus 19.8. Negative 2.8. 16 minus 19.8 equals that's negative 3.8. And then 19 minus 19.8 equals negative 0.8. Alright, so let's complete step 2 right here. Now we move on to step 3. I like writing it up here. Step 3 is deviation squared. So let's finish out our graph in green. Deviation squared. Or table rather. And then we'll write these numbers, these values in purple. So that's negative 4.8 squared. This in here, 4.8 squared is 23.04. Then 2.2 squared. This is going to be 4.84. 10.2 squared. -104.04 -2.8 squared equals 7.84. And then 3.8 squared -14.44 -0.8 squared is going to be 0.64. Okay, so now that we have that, we can move on to step 4. And again, all this is sum of deviation squared. So we're taking every one of these values again and just adding them up. So 23.04 plus 4.84 plus 104.04 plus 7.84 plus 14.44 plus 0.64. And then again, put my calculator back in frame. This is going to be 23.04 plus 4.84 7.84 14.44 plus 0.64. So this equals total 154.84. Okay, so now we can just move on to step 5. Once you break these down into steps like this, it makes it really easy to see what you're doing, going step by step. So, step 5, plug in step 4 value. Into your formula. So then we got our formula again. Same concept. Deviation squared is plugged in here, and then the summation is, we've already found this whole line. This is more daunting than what it is when we break it down into steps like this. It makes it a lot more easy to see. So sigma, or S, for standard deviation, is going to equal the square root of 154.84 all over. Like we said before, it's a sample, so calculate n equals 6, so 6 minus 1, so 154.84 all over 5 is going to equal 54 divided by 5, 30.8. And then same thing, square root, second, the negative sign to get the answer that we found previously under the square root, and hit enter. This is going to equal 2 decimal places, so 5.5. So So that's basically all there is to it. But what does this value actually mean? So what this means is how close are we in our data set to the average of the data. The only time that you can use this is on a normal distribution. So what that means is normal distribution. So if you have the graph of your data, it's going to be a perfect bell shape. So what that means is, you know, your mean value is in the middle of your data. The only time that you wouldn't be able to use this is on non-normal distribution. So, and what that means, like this is normal, and then on non-normal, graph, what this means is that your data is skewed by a value. So let's say, you know, it started out, but then you have this tail on it. And what this does to your data is, instead of the mean being here in the center, this is going to be closer to your median value, and your mean is going to be closer to this tail. That's what, when your data is skewed, the mean always shifts with that tail. So this is a positive skew, right? For this example, so like what are some examples of how this could have been skewed? Say you have like 100 students, and then 80 of those students scored, say 80 to 100% on a test, but then you had 20 students, say they scored really low on the test, so they were in like the 40 to 60% range. So in this example, I mean, it would skew your data to the right and be negative, basically. So again, this tail has skewed it to where the mean shifted closer to this tail. So like the majority of the students are on this side of the curve, but the outlier, you know, this number here, that's going to be your outlier. And all that does is that is the value that shifts your data and moves your mean. So it makes it to where if you use standard deviation, it's not as accurate. You would actually need to use the median value here to be more accurate. And then in the examples that I've used, we don't have any units on these, so we really can't tell based on this if we have a high or low standard deviation. So a low value, high value, the only thing that means when you're dealing with this is low is really close to the mean, and then high is scattered farther apart. And you're going to get this on any example on a normal distribution. So, you know, a low, the only thing that's going to mean is you're going to have a higher bell shape. So this is low, and then on a high one, your bell is going to be more flat. So I I think that's the end of this video. I'm going to leave it there for now. I hope everything that I've showed really helped and cleared up a few things if you had any questions. Thank you.